Yeah. Good morning, all, and thanks a lot for taking your time on a Saturday morning and joining us on this session, which is about monitoring Kubernetes applications with Prometheus. So I have with me Dimple, Raja, Vamsi, and Yash, who will be the speakers for the day. So a quick intro about Dimple. So he's a senior member of technical staff working at VMware on Tanzu Kubernetes Grid, that's TKG. And he's passionate about building and designing applications across virtualization, containers, on-prem, and cloud domains. Thank you so much, Vamsi, for accepting our invite. And
thanks, Petra.
And moving on to Yash. Yash is a member of technical staff currently working with VMware to build Carvel, a set of open source tools recently donated to CNCF. So he is an enthusiastic open source contributor, and he's also one of the web developer, and he's more keen about DevOps as well. Hey, thanks, Yash, for joining us. Thanks for your time.
Thank you, Mitra.
Yeah, so over to you, Vamsi. I'll probably make you the host, and you can take it over.
Yeah. Hey, hi, folks. Good morning, everyone. Before starting, I just want to see if the font and I'll just share my screen. If the font is too small or anything, just let me know. I'm actually using a bigger monitor, so is this font okay, or do you want me to increase it a little bit further?
Can you increase it a little bit?
You want to increase it further?
Yeah. Yeah, this looks fine.
This is better.
Yeah. Okay. Let's get started. So yeah, so monitoring Kubernetes application with Prometheus. So that's what this workshop. So I think Pavitra gave us a nice intro of us. So, but just to give a little bit more brief, so I work on something called VMware Tanzu, which is nothing but spinning up Kubernetes cluster. So I essentially work on let's say you are a customer and you want to have a Kubernetes cluster. So I work on a space where we make easier for customers to spin up the Kubernetes clusters on the vSphere environment. So that's what I primarily work on, and etc. Ash, do you want to give any other intro about yourself?
Yeah, sure. So myself, Yash, I'm working with VMware and working on Carvel open source like set of tools. So it's a whole set of tools in which help you in deploying, building, and configuring the application on Kubernetes. So it's the tools that are built on the unique strategy, like each tool solve a single use case. So yep, so that's where what I'm working on. That's pretty much about me.
And the next, so yeah, the agenda is pretty much simple for today's workshop. So we will try to understand what do we mean by the monitoring. So what is monitoring at all? Then we will touch base upon the what is Prometheus, what are the different components, and there are a lot of things when you talk about Prometheus, right? So there is a push gateway, etc. Alert manager. There is Grafana comes into picture, which is not a part of Prometheus stack, but yeah, it is part of the monitoring stack. So there are a lot of moving pieces that comes into a picture. So we will try to understand what are those things. And so we have a hands-on session. I hope we uploaded the code to a GitHub repository. We will share it over the course of this workshop in the next few slides. You can actually get that piece of code and try to run it on your laptop. The only constraint is if you have a Docker running on your system, that should be good enough. And you should be able to log into the Docker Hub and get the things working. And for one of the hands-on thing, you might need to create a Slack thing, which is straightforward. You can do it in 5 minutes. I will just show it to you if anybody wants to do it on the thing. And then that's where we kind of conclude most of the things. That's where most of the time will be on. And what's next? So it's kind of like, now you have learned about the Prometheus and all these things. So what's next? So there are some limitations to Prometheus, how we are going to handle those limitations. What are the other projects that kind of helps us to get back from these drawbacks or limitations that we have from Prometheus. So that's what these are the four main important topics that we are. And if you have any questions, like Pavitra mentioned, please feel free to put it in the chat, uh, or else please do. I will try to give a preferred time slot for Q&As for each and every session, and there will be some breaks in between for your bio breaks and etc. But feel free to stop me if there is something you want me to quickly sort it out. Okay, so the first part. So what is monitoring? So this is one of the definition that I just picked it up from the. And one more thing that I want to highlight is for most, I will upload the slides to the GitHub repository, and you can just find the references in these particular links. So I try to provide as much as information. Most of the information is not present in the slides, but in the references, you can just go ahead and refer to it. So that's how the slides are kind of organized further. Yeah. So again, getting back. So what is monitoring, etc., all those things. So monitoring is nothing but, as you can read, it is nothing but collecting, processing, and aggregating and displaying real-time quantitative data about a system, blah, blah, blah. So to put it short, so monitoring is kind of like you have some data, you have a service, you generate some metrics. Metrics is nothing but you generate some data when the service is running, and you should be able to use that piece of data, and you should be able to display that data in such a way that you know what is happening in the system and what going to happen in the system, etc. Those kind of. So that's what monitoring is all about. So you just collect and you process the data and you aggregate the data. That means you do some processing on the collected data, maybe like some all the metrics and display, etc., those things, and displaying. So you will get more understanding what the definition means over the course of this workshop. But yeah, so why we need monitoring in the first place? So why we need this at all? So that's where we need, so these are the four main points that why we need the monitoring. So let's say you have a service and you are giving it to customers, and you need to make sure it's a cloud service, right? So you are providing a cloud service to the customer, and you need to make sure that you have some set of the service when it is invoked or for API requests or anything, 95% of the request will be successful. So that's what the agreement that I am giving to the customer, right? So now, how do we make sure that we meet that particular agreement? That means if we doesn't meet that agreement, we have to again pay back to the customer. Okay, our agreement was broken, so we will again give back money to the customers. So to do that, so we need monitoring. So we analyze the trends. So how the API requests are coming, what is the load on the system? And if the load on the system is very high, then we need to scale in or scale out the application accordingly. So for that, we need to know, so when the load is very high, we need some kind of alerting. And then once you have the alerts and trends and everything, you need dashboarding. Dashboarding is kind of gives like, so what is happening over a course of time. So let's say you want to look at what happened past 6 months, what happened past 6 months, so that you can decide your next steps. Okay, this is how in the previous 6 months. So on this particular holiday season, we have a lot of requests. So we have to scale out the application. So accordingly, you need dashboarding, and also we can use for debugging. So all these things. So that's where if you look at this carefully, this is what the monitoring tries to answer: what is broken and why it is broken. So that's what it is. So monitoring should address what's broken and why it's broken. So that's what the monitoring stack is all about. So it's not only about metrics or anything log per se. So I hope there is one more session. I think that was the last session in this open telemetry. Uh, sorry, open tracing. So that's where you collect logs and try to see what went wrong from the logs and how to debug from the logs. So that also comes in as part of monitoring stack. So it's not only about you generate some bunch of data and do the monitoring. So when you say monitoring, it is from different perspectives. So from in this workshop, we will try to cover how Prometheus helps in the monitoring stack. So before going further, I just want how many of you know about this SLIs, SLOs, SLS? Have you heard about these terms in your day-to-day life?
Only SLAs.
Yeah.
Mm.
So yeah, I will just give a brief of what are the SLAs. So they are in this order, to be precise. So SLAs, you have the first. That is what you give it to the customer. So let's say I created an application, suggestions application or something, and I go to the customer and say, you use this particular cloud application, and the SLA that I'm giving is 95% of the time my application will be up and running, right? So that's what the agreement between me and my clients have. And now to achieve that particular agreement, we will have some set of SLOs. So SLOs are kind of like, so I need to make sure my service is up. So that's what my SLO is. So I need to make sure uh, that's what the SLO to my team is. Now the SLI is kind of like, so I need to generate. So how do I monitor the service, right? So there will be some set of, so you can look at the pod. So let's say you are running your application on the Kubernetes, you go ahead and take a look at kubectl get pod. You get like this is the time the pod is up and running. So you can see the pod is up and running for the past 1 day or 2 days. So what happened before that? Was there any crash loop back off or image pull back off or anything as such? So we need to understand those kind of data. We need that data. So that data is what the service level indicators that kind of dictate like how exactly the service is behaving. So yeah, so sometimes you might find the SLOs and SLIs are kind of cloudy. That means they kind of merge with each other. You can have a single SLI or SLO which kind of says the same thing. But yeah, this is what SLIs, SLOs, and these things. So essentially why we need this is because that's what the basis for any monitoring thing. So if you want to do monitoring, the first thing you need to ask for yourself is whether we have these SLAs, SLOs, SLIs defined for our application. So if not, that's the first thing that you need to come up with. So based on the SLAs, SLOs, SLIs, you will go ahead and make changes to your service, create dashboards, create alerts, etc., etc. All those things you do based on this. So it's from the top down. So first you don't create metrics. So you start from the SLAs kind of thing, those things, and then go below the project. So that's how you do the monitoring in any of the application, that thing. Any questions? Okay, so now let's get started with the Prometheus. So yeah, just a little bit intro on Prometheus. So it was something that was, it's a project that was founded in the SoundCloud and that was contributed to the CNCF. Uh, so Prometheus kind of collects the metrics in a time series data. So if you doesn't know what is time series data, it's kind of like, let's say you have a data point X you also store when that X was generated. So let's say I generated it now, I store June 17th, 2023 and something like 1025. And let's say after half an hour, you have one more data point Y, then you store the Y data point with the timestamp. So essentially it's a time series kind of thing. You have timestamp and you also have when the data was collected. So that's what Prometheus collects and stores. And Prometheus, the philosophy of Prometheus is purely based on the pull model. So let's say you have a service that is generating some metrics kind of thing. You just generate the metrics. You don't worry about how you are going to push the metrics to the Prometheus. Prometheus, you need to, when you're configuring Prometheus, you kind of provide some kind of configuration that you go ahead and pull the metrics from this particular service. That's what the pull model is. But yeah, there are essentially some scenarios where you cannot do that. That's where we have something called Prometheus supports push gateway. Again, push gateway is not something you push metrics into the Prometheus. Push gateway is another piece of software that is provided by Prometheus. Essentially, the thing is like you have a service that pushes the metrics to push gateway, and you configure Prometheus to pull metrics from the Prometheus. Again, it is a pull model. So whatever that is, Prometheus always pulls the metrics. But you can use push gateway to push your metrics in the like kind of a gateway kind of thing. And yeah, Prometheus also supports service discovery and static config. This is what I was talking about. Inside the Prometheus configuration, you just configure, this is where you need to pull the data from. This is where you can pull the metrics from, etc. All those things. Now, so far now we have Prometheus was able to pull the metrics, store the metrics and all those things. Now, the next part is how you do some kind of logic around those metrics. So that's where we have PromQL, which is domain specific language that you can run queries on this particular data to make sense out of it, to create dashboards. So how the data is behaving, how the data, let's say you have a metric called number of successful API requests, right? So that kind of keeps on increasing. So now you want to see the rate of change per minute or per hour or per something like that. So that's where you run PromQL queries to see, okay, the rate was increasing like 5 requests per second or 6 requests per second, kind of like. So that's where, yeah, we will discuss in detail what are all these components are, PromQL and push gateway, and what are the different kind of metrics and etc. all that. But yeah, so this is how the Prometheus architecture kind of looks like. So here at the center part, you have a Prometheus server and you have a push gateway where the short-lived jobs or the ephemeral jobs, which kind of like, that means it's a short-lived job, right? So you cannot configure a pull model from the short-lived jobs. So what you do essentially is kind of like, you have a push gateway in between where you push the metrics into the push gateway and you configure the Prometheus to pull from that. And then you have the normal services or applications or jobs or exporters, which are running continuously, like a server, which is running continuously. So you pull the metrics from this. How do you, so how you pull the metrics from this is kind of like you have something called service discovery here, where you kind of configure, this is where my service is. This is the endpoint, this is the IP end port of the service where you can pull the metrics from. So that's what you do the configuration. So the service discovery through which it can find out the push gateway and all these things. So this is one part. This is where collecting the data, and whatever the data that is collected, Prometheus actually stores it in the same node kind of thing. That means if you're running Prometheus on your laptop, it will store each and every data on your laptop itself. So that's kind of a limitation and drawback, which we will discuss in the coming slides. Then you have an HTTP server through which you can run PromQL queries. So here, that's where you interact with the HTTP server. Sorry. To run the PromQL queries. So PromQL queries is useful. So that's how you run the Grafana and all these things, web UI, and yeah. And then you have Alert Manager, which is a different component similar to Push Gateway. The primary job of Alert Manager is kind of like notifying the other applications. Like let's say my application has 95% of the time uptime. Let's say the service goes down. So now the Prometheus server, you need to configure the alerts in the Prometheus itself. Now, when that alert is generated, Prometheus kind of pushes that particular alert to the alert manager. And inside alert manager, you have the configuration, like if you have this particular alert, whom should I notify and how should I notify? So whom should I notify is kind of like, let's say there are multiple teams and you can configure like, okay, if this particular alert comes, create a Slack message on this particular channel, or send a pager duty notification, or send an email, kind of that. So that's what the alert manager job. It doesn't do any kind of processing or anything as such. It's just purely for notifying to the external applications when the alert is getting fired. So again, the alert manager configuration is part of Prometheus configuration, which we will see detail in the upcoming demo. Please do let me know if I'm going too fast or if you want me to slow down any of the thing.
I have one question about this push gateway. It is a server or the kind of a storage device?
Which one? Can you repeat your question?
Push gateway.
Push gateway is again a server, so that is running by itself. So it's a server that kind of, so every short-lived jobs, right? So let's take example of maybe one example I can give. Yeah, that we will see in the demo again. So you have an what we call you have an application. What it does is a customer, there are few customers in the line and there is a staff that kind of process the customer request. And once those requests are completed, there is nothing to do. And the other customer request can come later part of the time. So those are kind of ephemeral jobs, right? So this is a server that is running. So the job starts, that means the staff starts processing the customer request. Once the staff process all the requests, they push the metrics to the push gateway. Now the push gateway is a server that kind of stores those metrics, and Prometheus pulls those metrics from the push gateway. So it's a server. To put it short, it's a server. Okay. So now coming to the next part, the Prometheus metrics. Yeah, it will be a little bit boring, so I might this might be the last part. I have to cover this counter gauge histogram summary, these parts, the theory part. So later, after once this is done, I think we can try out. I hope everyone of you have a Docker up and running on your workstation that you can try out things, modify things, and play with the things, etc. Okay. So before going any further, right? So before understanding these different bits more clearly, so let's see what Prometheus has to offer. So Prometheus metrics. So Prometheus metrics has 4 types to be precise. So these are the 4 types that Prometheus supports. So anything that you want to instrument your code, or any metric that you want to generate, should fall into this one of these 4 categories only. So let's see what it is each one by one. So Prometheus counter. So like the name says, it's a counter. So it's always positive and it's always keeps on increasing, right? So here, example, this you use Prometheus counter when you want to increase how many times a particular API is invoked, right? So let's say you have an API and you want to measure how many times that particular API is invoked. So that's when you kind of use this particular metric. So here on the on the right hand side, you can see API invoke count, which kind of measures how many times this particular invoke. So these are nothing but these API name and success. These are nothing but labels. Labels are nothing but key value pairs. So here, this is what this particular first line is saying. There is a API name called beer, and the success rate is success equal to false. That means it failed 23 times. And the second line kind of says beer API is successful 7 times, and the car API is successful 30 times, and the delay API is successful 30 times. So that's what this particular snippet kind of says. So we will discuss more about the labels a little bit, but yeah, this is how the counter looks like. So you cannot again decrease the counter, so it keeps on increasing, and when the service restarts or something like that happens, you can again reset that back to 0. So that's the only functionality that you have with counter. So that's what Prometheus counter. And there is something in the similar lines of counter, but it's a little bit different. That is Gauge. You can increase or decrease the value of Gauge. So you can also set a particular value. So when this is kind of used is, let's say you want to monitor how many active HTTP connections. That is nothing but the load on the system. You want to monitor how many HTTP connections at a given moment of time, right? So the HTTP connection, sometimes it will be like 5, sometimes it will be like 3, and sometimes it will be 10, sometimes it will be 12. So it keeps on increasing or decreasing depending upon the load on the system or how the clients are interacting with the application. So that's where you cannot use a counter in this particular scenario, because you need to increase or decrease this particular value. So if you see this particular one here, right, this particular Gauge present connection. So it kind of says how many active HTTP connections that the particular service is having. So it is having 3 at present. So that's what the Gauge says. Again, you can have labels, etc., all those things, which I will give more. And the third metric is histogram. So histogram and summary are a little bit more complicated metrics. So essentially, why we use histogram and summary is because of this reason. I hope many of you heard about when you are doing CAT, right? When you are attempting CAT, so there you won't be getting ranks. You will be getting what 99 percentile, 95 percentile, 99.99 percentile, something like that. So what does that percentile kind of actually mean? So it kind of says like, let's say there are 10 people, and one of the person got 10 marks out of 10, then he will be in the 100 percentile. 100 percentile is kind of fictional. Yeah, he will be in the above 99 percentile because he got the 100. And 50th percentile is nothing but median kind of thing. So that's what. So again, coming back to our thing. So where we use these percentiles. So again, if you go back to our discussion in the first session, I mentioned we have an API, and we will say that particular our service level agreement for that particular API is kind of like this. 95% of the request will be completed in 5 seconds. So that's what my service level agreement is. So that means my 95 percentile value should be 5 seconds. So that's what that particular service agreement translates to the metrics level notation. Yeah, but we will see a little bit more on that. So histogram is kind of like, I hope you have already seen the histogram metric. So there will be buckets. kind of like this kind of says like, so here I have like 10 buckets, 1, 2, 3, 1 to 9, and the plus infinity is like the maximum value that we can get. So we have 10 buckets here, and there are 5 requests that completed in less than 1 second. And there are 9 requests that completed in less than 2 seconds. And I just want to highlight Prometheus histogram is cumulative. That means 5 plus 4 requests completed in less than 2 seconds. So you might see histograms kind of instead of 9, there can be 4 also. That kind of says like how many requests completed greater than 1 second and less than 2 seconds. But Prometheus histogram are kind of like less than 2 seconds. So anything that comes in 1 second will come in 2 seconds also. Similarly, less than 3 seconds, you have 5 requests that fall in between 2 and 3. So if you see, there are around 28 requests that got completed in less than 9 seconds. And if you see the medium, that falls around, we have 30 requests in a total, right? So that is 15. So the median is somewhere around 4. That is nothing but 50th percentile. So this is, I am doing the calculations in my mind, but you have PromptQL through which you can do the calculations on the server side. In the Prometheus, you just type some histogram, quantile, etc., etc. Some commands you do, and you get the data on the fly. Again, one more thing that I want to highlight is the computation will be done on the server side. So the only thing that is on the client side, so these metrics are generated by the server, right? So they kind of put it in the buckets, and the quantile computation will be done on the Prometheus server. So that's what this server side computation means. So this will be done on the Prometheus side, not on the client side. So summary, again, the summary is kind of almost similar to histogram, but with a little bit different. So it is also used to calculate the quantiles, but the major difference is you calculate the quantiles on the client side, in which case our application. So when you are doing the processing the request, you calculate the quantile on the service itself. You don't push the metrics to the Prometheus and let Prometheus calculate the quantiles. So that's what the summary does. Is so essentially you need to have again the buckets here. So quantile equal to, this is 0.5, that is nothing but a median, and 90% of the request completed in 10 seconds, 99%, of course it will be in 10 seconds, and 50% of the request completed in 8 seconds, which is very bad, which we discussed, right? We want 90% of the request should be completed in 5 seconds. But if you see, they completed in 10 seconds. So we breached our service level agreement. So that's what the computation happens in the on the application itself, not on the Prometheus side. And if you see the histogram and Prometheus, right, you have histogram and Prometheus generates the sum and count. So count is nothing but number of observations that we have seen, and sum is nothing but the sum of those observation values. So you observe 30 observations. So here we have something like 30 requests, and all those 30 requests completed in 123 seconds. So that's what this particular sum and count kind of gives. And this infinities bucket is kind of default. That means, let's say I provided the 9 buckets, then Prometheus adds one more bucket to it called infinity bucket and pushes everything. It is infinity bucket. The value of infinity bucket will be nothing but histogram count. So that's what it is. And similarly in the summary also, it will be the same thing. You have sum and count. So sum is nothing but all the observations value, sum of all the observations, and the number of observations that we have seen. Any questions that any of you want me to elaborate on this? Okay. Okay, so labels and cardinality. So till now we have seen these quantile equal to 0.5 and LE equal to 1. So what are these? So these are nothing but labels. So this is what we call, so labels are nothing but key value pairs. So if you see here, right, so this is one example that I can use when to use labels, when not to use labels kind of thing. So here you have API invoke count metric, so which is a counter, and I want to calculate how many times the API is invoked, but I want to calculate for each and API, for every API request, kind of like I have two APIs, one is beer API and one is car API, and I want to measure how many times beer API is invoked, or car API is invoked. So I have two approaches I can do this. So one is I can create a counter called API invoke count beer, or else I can create another counter API invoke car. So I can create something like this, or else I can create something like this. API invoke count is a metric with the label API equal to beer, API equal to car. So I can do this. The major difference is the flexibility that you have. So let's say you added one more API into it. Then the only thing that you need to do is just add one more label API equal to new API. But in this scenario, the second scenario, you need to create one more new metric called API invoke count new API and calculate the things, which will be, so you need to decide. So when to use labels, when to not use labels. So that's where, again, if you see, these are two different metrics. So that means when you are storing this particular data in the Prometheus, right, you are storing the first line as one data point and the second line also as a one data point. So you need to be careful when you are adding more and more labels. So let's say I added one more label to this particular one, then the cardinality of the matrix increases. That means API has two, so this particular API has two different options. That means right now this particular API can have two different data points at any given point of time. Now let's say you added one more label called random, and that particular random label key can have three different values, right? So that means you will have 2 into 3, that is 6. So you will essentially have 6 metrics at any given point of time. So you are overusing the labels. So that's why when you are doing, using labels is good, but then again, overusing labels is bad. So you need to make sure when to use and how to drop the labels and etc. All those things you need to be careful so that you don't overload your metrics and make things complicated. So here, as you can see, each label set, that is nothing but this is a label set, consumes RAM disk. So essentially the philosophy is use labels, but don't overuse labels. So now, again, going back a little bit, so we have Prometheus, histogram summary, gauge, and counter, right? So if you look at the gauge, right, carefully, you can also use that as a counter, right? So let's say you have a gauge and you don't decrease the value, you are essentially creating a counter. But counter was specifically created in the scenarios where you doesn't want to see increase, but essentially you can use gauge also as a counter. So there are few primary reasons why we have different why we have two different metrics which kind of perform the same. That means counter versus gauge, right? So it is because there are some PromQL functions like rate of increase. So let's say how many requests I'm getting per second. I want to calculate that particular data. So that's where you need to have a metric that doesn't decrease at all, right? So if you want to use that particular function, you need to have a metric that doesn't decrease. So in that scenario, you cannot use gauge. Again, like I mentioned, if you want to use gauge and compute the increase or rate, you need to make sure that you are not decreasing the value of Gauss. So that's what the primary difference between Gauss and counter. So make sure it fits your when you are dealing, when you are working, when you are creating the metrics, make sure which particular metric type that you need based on that. Go ahead. And one more rule of thumb is kind of like Gauss represents a state kind of thing. So let's say you want to monitor the temperature of the system. So that is a Gauss because it kind of keeps on changing. It is the state of the system. So it kind of keeps on changing. So that's where you need to use Gauss. You cannot use counter there, right? So you need to make sure when to use counter, and that's based on these set of philosophies, set of guidelines, you decide which one to use. Again, the same thing is, so histogram and summary. So they are kind of does the same thing. That means the primary purpose of histogram and summary is to compute the quantiles. So now why we need two things, right? So why we need two things? If you look at the histogram metric that we have seen before, here we have decided these are the buckets that we have, right? So every request will be less than or equal to 10 seconds. So that's what I know the specific range of the delay that I have. So that's where I can use the histogram. So if you doesn't know your range, that means if you cannot segregate the data into buckets, that's when you use summary. So let's say there is an API and that API takes a lot of time and you doesn't know how much time it takes, to be precise, because you are in the implementation stage, you doesn't know how much time it takes. So that's where you use summary. You cannot use histogram because you don't know the time limit of that particular, let's say that particular API completes in less than 10 seconds, then you can kind of create the buckets like 1, 2, 3, 4, 5. But the general guideline of creating the buckets is exponential. So you start with 1, you go to 2, then you next bucket will be 4, next bucket will be 8, something like that you do. So you create the buckets exponentially. So this is bad way of creating the buckets. Again, if you look at here, here I have a label called LE, and there are 10 possibilities for that label. So at any given point of time, I am storing 10 different metrics, 10 plus 1 plus 1. That is, if you are creating a histogram, you are essentially creating 12 data points at any given point of time. So care should be taken when you are creating the buckets also, so that you don't explode the number of buckets that you have. And for summary side, these buckets are nothing but the quantiles that you want to compute. So let's say you only want to compute the 50th percentile and the 90th percentile, then you don't need to generate 99th percentile, the quantile value. So you can just drop this. So this is just fairly simple. But then again, when you're using summary, the computation happens on the application side. So if there is a lot of data, then the processing happens on the application side. So the care should be taken so that you don't compute for long. So that's one of the major difference between histogram and summary. So another rule of thumb is if you want to aggregate, choose histogram. So kind of like this, take this example, you have two different applications. So most of the times when you are running applications on the Kubernetes, right, you will have more than one replica. So you have 2, 3, 4, 5, etc. all those things. And if you generate summary for all those replicas, so you will end up having, let's say I have the application that I was creating have 5 replicas, right? And now out of those 5 replicas, I generate the summary of the time. So I cannot make sense out of those 5 summary data. I cannot accumulate the data in the Prometheus server and make a sense out of it. This is primarily because the algorithm that was used in generating the summary. So you cannot combine multiple summaries into a single summary. So that's where histogram comes into picture. So histograms, you can combine multiple histograms on different places and generate a quantile out of it. So that's what the computation happens in the Prometheus. But you cannot use summary in that scenario. So if you need to aggregate, choose histogram. But if any one of you are interested in learning more about the underlying algorithm of the summary and how it affects uh, cumulative adding up the summary values. So you can just take a look at this particular blog break from the Grafana team, how summary metrics works in Prometheus. So that's very good. You can just take a look on that. Okay. So before going further, I can take any questions that you need. Okay. So this is where the demos kind of starts. Mostly from here, from this point onwards, I would like all of you to give it a try. So the things that I will be sharing, right? So we will try to help you with any of the workstation, but yeah, depending upon the time, that's purely depending upon the time, we'll try to help you. But mostly everything, like I mentioned before, will be run in a Docker container application. Okay. So for this particular demo, right? So for this particular hands-on thing that we are going to do, so we have an application called suggestions application. So all of the samples that I have showed before are actually from this application itself, so that you can correlate the things better. So this particular suggestions application is kind of like this. So you have a HTTP server which is running on the 8089 port, and we use something called go fake it library, so which is nothing but uh, so it's a random generator library. It generates data randomly, so you can just take a look. It's a very good if you want to try out demo things or anything like that. So we use that particular go fake it library to generate our random data or suggestions data. So as the name suggests, the suggestions application, right? So here we have three suggestions, three APIs. One is car suggestions, which kind of gives the car name. It suggests a car name, and beer suggestion, it kind of returns a beer name, and delay suggestions kind of suggest how many seconds to delay. And there is some caveat in the beer and delay API. So beer API kind of fails randomly. So it fails, like it mentioned, randomly, right? So it might succeed, it might fail, but car and delay API always succeed. And there is one caveat in the delay API. So it kind of suggests how many seconds to delay, and also it process the request for that many seconds. So let's say the delay, when you invoke the delay API, you get a response like 7 seconds, like the value 7. That means the delay API delayed for 7 seconds. So that's what it happens. That means it sleeps for 7 seconds and then returns the value 7. So that's what it is. So we use go fake it library for the car suggestions and beer name suggestions. So again, I'm not doing anything fancy here. So this is what I'm using from the go fake it library. So here you have different car suggestions kind of thing. So you can just take a look at this particular piece of code. Similarly, the beer, you have here that kind of gives you different beer names and etc., all those things. Yeah, delay, I'm generating the data randomly using rand function. And then we use something called Go Prometheus library. So it's an official Go client. So Prometheus client Golang. So so this is what we use to generate these metrics. So we want to generate these metrics. So Prometheus provides the Go library for generating those metrics. So we use Go Prometheus library to instrument all the 3 APIs based on our requirements. And here we have two more endpoints. So the first endpoint is metrics endpoint. So that's where you publish the metrics that are generated in these 3 APIs. And you have default metrics. This is primarily because when you use Go kind library, right, it kind of gives some default metrics like number of Go routines, or Go routines is nothing but number of threads. Essentially, if you are a person that working on Java, you also have Java Prometheus library. You can use that also. Not in this. I hope at least some can read the Golang code. I forgot to ask that. So how many of you know about Golang code? Doesn't know, actually. Okay, no response. I don't know how to take that.
I don't have.
Okay, so I will just give a brief, not exactly the Golang per se. It will be same in Java or anything. The philosophies or the guidelines that I will be telling, right? So they will be same in across anything. But yeah, so if you are using Java, I think Java Prometheus library provides number of threads that are running in the application and the number of the amount of memory used by the JVM, etc. All those things. If you are using Golang, the corresponding metric. So Prometheus kind of provides that default metrics when you import the library. So that's what we will look at. What are the default metrics, etc. So yeah, so this is our suggestions application that we are going to do things about. And yeah, so these are the SLIs or SLAs or SLOs that we have defined kind of thing. So our API success rate should be greater than 70% of the time. This is an SLA, sorry, this is an SLI or SLO. And the service level agreement for this would be something kind of like we will make sure that our API will success rate will be greater than 70. Again, that's the same thing in a different format, in a nice with quotations kind of thing. And number of active connections shouldn't be more than 5. So for this SLA should be the load on the system at any given point of the time will not be more than 5 requests kind of thing. So these are, so when we breach these particular SLIs, right, we need alerts. So we will try to see how to generate the metrics, and then how to configure the alert manager to generate alerts when we breach this particular threshold kind of thing. So that's what we will try to do in the next 1.5 hour to 2 hours thing. And yeah, you can find code and slides. I haven't uploaded the slides yet. I will upload in an hour or so these particular slides, but you can find the code in KCD Prometheus workshop. You can actually clone this particular repo. Okay, as we are almost 1 hour, I will just give a break at this point. You just all of you folks can clone this piece of code and keep it in your laptop ready. I think we can again reconvene back in maybe 5 to 10 minutes, maybe at 10:10, or is it too small break?
11:15.
Yeah, sure, go ahead. So we will again reconvene back at 11:15.
Yeah, sure. Sounds good.
If anyone wants me to elaborate anything, I can just take those questions.
For this demo, I have to have Docker, is it?
Yeah, you need to have a Docker running on your system.
Minikube will not work.
Sorry.
Minikube will not work.
Minikube, you have to set up things in that Minikube. But yeah, so everything I have run it based on the Docker. If you have you can try to run it on the Minikube as a pods, but then yeah, that is something I haven't tried. You might face some issues.
Yes.
If you have Rancher is also fine. Rancher desktop, you can also use that. Fine. Is this browser font good enough?
Yes, Vamsi, yeah, this should be good.
Yeah, thanks. I hope everyone is back. I think we can get started. So I hope everyone cloned this particular repository that has the code. So I'll just give a walkthrough of the repository. So we have, let me just refresh. So I uploaded the slides. You can find the PPT of this particular session here for the reference links and everything, right? So that I was talking about. So the reference link. So this will be helpful a lot. So you can just go that. And here, this particular folder server, so it has the suggestions application. So that's where we have the application that we want to monitor actually is. And Prometheus folder contains different Prometheus configurations and etc. All those things. And alert manager contains alert manager configuration, and this is the client. So this client, as the name says, we use this particular client to invoke the suggestion APIs, to invoke, to instrument, to simulate some failures, to simulate the general workflow on how clients invoke the API. So that's what, if you look at, this is just a single file. This kind of does, it goes to each and every API. So invoke API. So it goes to each and every API and invokes this particular HTTP API. So API string, and you see, so we have car API, we have beer API, and deal API. So that's what this is a just simple program that kind of runs as there are few people who doesn't know about Golang, right? So concurrent routines are nothing but you can assume it like we are running 3 threads and there are 10 iterations. That means we kind of invoke each API 3 times. That is 1 iteration, and that goes until 10 iterations. So we kind of invoke the API 30 times in this particular. And there is a delay of 120 seconds between each and every, after every 3 invocations. So that's what. So this Go invoke API is nothing but in Java or C++ or C, it is nothing but creating or forking a new thread kind of thing. So in Golang, it is Go routine. So it kind of seems like a thread. You can assume it like a thread. And here we are just waiting until all the threads are Go routines are completed. So that's what this client program does. And here we have Grafana. This particular folder has some JSON files. Grafana we primarily use for dashboarding and visualizations. So that's what. So once we instrument our suggestions application, right, we generate the metrics. So we configure Prometheus, you configure alert. Then we need to visualize the data properly so that when we have any, we want to see how the data is flowing and how the data is changing over the course of the when it is up. So that's where we have this suggestions dashboard, which kind of gives like different dashboards, 4 or 5. We will also create more. So that's what this folder contains. And install Kubernetes. So this is Kubernetes is a project under Prometheus operator. So whatever we are doing on directly Prometheus. So let's say you want to do it in the Kubernetes way. That means how many of you know about CRDs? Okay, on. So
Custom resource definitions, right?
yeah, correct. So custom resource definition. So so essentially, when you are configuring Prometheus, right, you provide some bunch of YAML files. Like this is where my particular application relies. This is where you need to pull the application metrics, etc. You do all that configuration. So let's say you want to do it through the Kubernetes way of things. Like you create YAMLs you create some more different YAMLs, you provide the configuration there, and you have something called Prometheus operator. But yeah, we will discuss, I think Yash will discuss more about Prometheus operator and how to install all that part. And this Prometheus folder, I think I've already given a gist. And this is the job folder. So job folder, like I mentioned, this is an ephemeral application. That means it runs, it generates metrics, pushes the metrics to the push gateway and dies. So that's what it does. So if you look at this particular application, can see that this is the push gateway URL, which is nothing but KCD push gateway, blah, 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 all that thing. So there is a metric called a job delay, kind of like, as I mentioned before, right? So there is a staff that process some customers requests. So how much time? So what we are calculating is how much delay the staff made for each and every customers. So what we are doing, so when you start this particular job, right, there will be 5 customers and there is a staff. We also push the staff name as a label. So again, if you see, we are generating using Go Fake It library. I hope Java also does have similar, but yeah, I'm not that well versed with the Java thing. So we are generating the name randomly and putting it there. And we also generate the customer name. This is, yeah, sorry, here. So this is, I think there should have been a customer name. So this is the customer name. So we are just, this is kind of like this. So this particular staff called Dimple processed this particular customer request in 5 seconds. So that's what we are trying to push. Again, the time consumed, we are generating randomly here. So the time consumed. So that's what we are trying to do. So this is an ephemeral job, push the metrics and dice out. So again, if you look at each and every, most of the application Go code, right? So you will also find a Docker file. So in the Docker file, it's pretty much simple. You don't need to, I'm not expecting you folks to have Golang installed on your system. If you have, then one flexibility that you can have is kind of like, you can open the source code, you can navigate, you have the everything indexed using the VS Code, right? So that's what the flexibility that you will have. If you doesn't have, also it's fine, because the compilation of the Go code, everything happens inside, this is what the compilation, everything happens inside the Docker container. So you don't need to essentially have that. If you have it, it's good. And then once we compile the code, we just make sure it is executable and start that particular application. If you look at the client, it's the same thing. So here you have the builder, the Golang, you compile the code, and then you just start that as a Docker application. So all this, and Grafana Prometheus, we are just pulling it from the official Prometheus Docker Hub. We just use that. It's of the prom/. So this is the official repository for Prometheus. So you can just so this is where we are pulling the images from. And if you see, it has all the images available for different workstation, if you are in Windows or if you are in Mac or if you are in Linux, right? So you shouldn't have any issues with whatever we are doing it here. I think I will close this. I will close this. So yeah, so all the applications, we will run everything as a Docker applications. And last but not least, so we have something called, this is for workspace. If you are trying to import the code on VS Code, right? You can just double click on this. It will open something like this. It will open for you something like this. So you can just actually browse the code better. You can see the each individual folder, everything like this. And yeah, makefile. So if on your system, if you doesn't have a makefile, which is the case with Windows, right? If you doesn't have make, then the only option that you have is running these commands manually. So just run these Docker commands, which you can run it on Windows also. So just run these particular commands on Windows directly. If you doesn't have the make option, if you have the make option, that would be better. So that's what I am going to show you. If you doesn't have, then you need to run these commands manually using your command line prompt or anything like that. And yeah, so whatever explained, yeah, that's what the folder structure is. And for running, if you see here, right, I just gave the commands. Don't run it now. We will go through step by step because we want to understand things, how the things are working, right? So this is what essentially we will be doing over the next 1.5 hour or 2 hours. Make setup, make run server, etc., all that. Okay. Before going to the PromQL, right? So for running PromQL queries, you need to first generate the metric. So that's where we will look at. So as I mentioned before, here you have the server application that is already there. Does anybody wants me to increase the font size a little bit further, or is this good enough?
Good for my side, but yeah, if anybody feels like the font size has to be increased, you can feel free to put it on the chat or you can unmute it. Okay, Karthik.
Thanks, Karthik. Okay, so now again going back and looking at the code, right? So this is what this particular main function does. You are getting a logger, creating a logger, and starting the server. So here you are just creating the mux or nothing but the handler, and you are providing slash metrics point should be handled by this Prometheus handler, and beer.suggest and car.suggest suggest. And if you look at the actual code, what this is an interface. So if you look at beer, right, the beer API, and if you see the suggest function here, so this is what it is doing. So we are getting we are again using the GoFakeIt library to generate a random HTTP code. And based on the HTTP code, if the HTTP code is 200, that's when we will return successfully. That means the beer API is successful. If you look at the previous slide of our application, beer kind of fails randomly. So that's what this means. We are generating the HTTP code sample randomly. And if you look at the actual HTTP code symbol, right? But and well interrupt. So these are the different HTTP codes that it generates randomly. So there is a possibility of these are like 6, right? So something around 15%. So 15%, only 15%. The probability is 50% of the probability that we will be the beer API will be successful. Most of the time it fails. So yeah, essentially this kind of fails most of the time. And yeah, so, and if you look at the car API, so it is nothing, plain and simple. You again use GoFakeIt library. There is an car function that kind of returns a car name. or car info with everything. That means it returns most of the info about car also, but we only need the car name actually. So so that's what we are getting. So so that's what we are doing, and we are returning. So we just return that particular data. And delay, again, the delay is same thing. We again use inbuilt random integer generation function, and the max delay in seconds is 10, and the minimum delay is 0. So that means there is a possibility that the delay will be 10 and the delay will be 0 seconds. So that's what, if you look at this part, we are just sleeping for that many delay seconds. And then we will return that particular value to the user. So let's see how it looks like when we run. You can also run this if you doesn't have make, like I mentioned, just run this particular if you doesn't have the make, right, you can just run this run server. So first you need to run docker build -t -kcd, then just run this and then after this, before doing any of this thing, just make sure you run this particular command. So just for the, by the way, how many of you doesn't have make on your system? That means to try out. Okay, I'm assuming everybody has make on your system as of now. So I will just use make file, then make commands to be precise. Okay, so the first thing that we need to do is make setup. So it setups a network for the pods to run. So we want all of our applications, that means the Docker applications, to run in a single network called KCD network. So I just created that particular KCD network. Now the next thing is I want to run the server. You can also build and run. So run also invokes the build before running the server. So you can just so if you look at Docker PS, so you have the server up and running. So as I mentioned, the server will be running in 8089 port. So if you again go back to your browser, 8089. So let's invoke the car API. So if you see, it has returned me the type passenger car light with fuel, CNG, and transmission manual. Brand is Hyundai, and the model is Outback AWT. It was manufactured in 1953, which is not useful. But yeah, this is what the car API gives. And in the meantime, let's look at logs also, how it is. So we have the logs generated by the server. Okay. So you invoke the car API just before, so suggesting car. So that's what this was doing. It is suggesting car of this type. That's what the response it did. And now beer, so failed to process. So we got an error here. So if you see failed in processing HTTP code 302. So you can invoke this multiple times. Founders break first out. Okay, we got a success. Seems like I'm lucky. So I got a suggestion. Founders break first out. I don't know what that is. Again, if you invoke it again it failed. Okay, it failed. Again, I got, after a lot of retries, I again got a success. And if you see, there are a lot of failures. So that's what this particular beer API kind of does. And last but not least, the delay API. So the delay was 0, so it returned fast. So let's try to invoke it again. Oh, again it was 0. Sorry, I think it is processing the request, so that's why it was getting delayed. So it waited for 4 seconds in this particular. So let me again do the thing. So it is still running, if you can see here. This is the maximum that we can get. So we got 10. So it is 0. That was fast. So that's what the delay API does. And yeah, and if we again go back to this thing, so this is what we have seen. These are the 4 APIs that we have seen. And now let's, this is one more called a metrics handler. This is for generating. So let's say you have generated all the metrics. Now you want to, so as I mentioned before, Prometheus is a pull-based model. That means you need to, once you generated the metrics, you need to serve those metrics at a particular HTTP endpoint. So by default, Prometheus expects /metrics endpoints is the endpoint where Prometheus will find all the metrics. Otherwise, you can configure Prometheus to look at a different endpoint. That is also possible. But /metrics is where most of the applications like Kubernetes API server or kubestate metrics or anything, most of the applications that generate Prometheus metrics, they kind of put it in the /metrics endpoint. That's where the things are present. And like I mentioned, default metrics is where the default metrics are present. Let's take a look at the metrics a little bit. So using this application, right? So we are trying to create all the 4 metrics. So we will create a counter, we will create a gauge, and we will create a histogram, and we will create a summary. Again, let's go back to our SLIs or SLOs. So API success rate should be greater than 70%. So in this scenario, what we should be using? So we should be using a counter. So why? Because we keep on getting the requests and we keep on getting success or failure. So it kind of always increases. So we don't want to use a gauge in this particular scenario. So we will try to use a counter for this API success rate to hold the data, how many times the beer API is invoked, how many times the car API is invoked, how many times blah, 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 all that. So we essentially create a counter and instrument our code to generate that particular data. Now for the second SLI or SLO, number of active connections. So sometimes, let's say you are invoking continuously, then you will have more connections available. So in that scenario, so it can go up and it can come down. So essentially, it's a gauge. You cannot use a counter in that particular scenario. So we will use counter. So we will use gauge for the second scenario and counter for the first scenario. And also we have this delay API, right? Which kind of delays? So we want to calculate how much, how many requests are getting processed at the median time, like 50%. What is the 50%? We want to see how random it is, whether it is spread across between 0 and 10, or is it far left to the 10 or 0, something like that. We want to actually do that. So for that, we will use histogram and summary. Histogram and summary we are using because we want to distinguish what is the quantile difference between histogram and summary. That means if you process the data in the application level or Prometheus level, so there will be difference between the quantile values between Prometheus and summary. We will take a look at that more. But yeah. So here we have this particular thing. And so if you look at this snippet, right, so there is something called help and a type, then you have the metric. So this is nothing but Prometheus exposition format or text format. So the data is in a text format kind of thing. So you have a help which kind of explains what that particular, you have a help with the metric name and what description of that particular metric. And then you have the type, which kind of says the delay summary is a summary. So essentially, this is a bad way of naming things, and I'm bad at naming. So you can just keep that as delay, because you already have summary type as a type, right? You don't need to explicitly again mention summary here, but just for the session, I have did that. And that's what this particular variables does. So what is the metric name and what is the description of that particular, or help to be precise. And then any questions? Okay, now the next part is before instrumenting anything. Again, this is applicable in any of the languages. It is not confined to Golang per se. At least the code is Golang, but the basics are same for Java or anything. So in the init metrics, right? So before doing anything, so now you got metrics and everything. So how does Prometheus, how does the application in the sense, in the suggestion application notes, what are all the metrics that you have across the application? So it doesn't know that. So that's why Prometheus provides something called registry. So Prometheus registry is nothing but it holds the details about all the metrics that are present in that particular application. So essentially, you need to create something like excuse me, you need to create something like Prometheus dot new pedantic registry or new registry per se. So it kind of creates a DB kind of thing, not like DB, just a in-memory cache that stores all the metrics. So now this particular registry we created, right? So once we created this registry, the next thing that we need to do, so we need to create the metrics, right? So Prometheus dot new counter vector, new counter, etc. All those things will create the metric. So once you created that particular metric, you need to register that particular metric with the registry. So this is what I am doing. If you don't register the metric, then that will be missed out. Even if you are updating the metric, when the API is invoked, it doesn't know that this particular metric was present or not, because it is not part of the registry, right? So that's what every metric you create, you register with the Prometheus registry. So that's only when you can also have multiple registries. So let's say you have a use case like you have something called experimental metrics and production metrics. So you can have two registries. One stores experimental and another one stores production. And you can have two different endpoints serving these two metrics at two different endpoints. So that's how you can actually, if we again go back to the main. So we are actually in the metrics endpoint. So here this metrics dot get metrics handle. So this is prom HTTP. So again, prom HTTP is nothing but the HTTP corresponding. This particular package provides HTTP handlers for doing your thing. So here what I'm doing is I'm providing the handle for registry. So this is the registry that I created at the top. So here, if you see, I created new pedantic registry. So that's what I am doing. So I'm just registering, I'm just creating a HTTP handler for this particular registry. Then in the backend, Prometheus client library takes care of converting these structures into a text format and putting that. As I mentioned before, if you have one more registry, right? So you can do something like this. Registry 2. And then just done it. And this you just create your own, right? So you are just creating a new pedantic registry, and you created this. So this is a, so now any development metrics that are going on, I can just register those development metrics for this. So this is what I have done for the default metrics. If you go and look at the default metrics endpoint here, right? So here prom HTTP handler. So this kind of serves the default metrics that we have. So I'm just using that default metrics, and I'm serving different metrics at a different endpoint actually. Now again, going back, if you look at the init function again, so I'm just creating the metrics when the service starts. So when the service starts, I'm creating this particular counter, and this is a connection metric, the number of connections, which is nothing but a gauge. So this is the counter, and gauge, and histogram here I'm creating. And then I have summary here. So I'm creating all these things. So if you look at each and every function, right, every metric will have these options. So you might find in Java also similar. So you have something called counter and counter vector. So counter is nothing but where you doesn't want to dynamically change the labels. Let's say you have label values. So in the counter, when you create a new counter, right? So you cannot change the values of the labels. But counter vector provides the ability for you to change the values of the labels. That means you have to define what are the labels, that label keys that you will have, but you don't need to define what are the values of those labels. So here, what I'm doing essentially is I'm creating a new counter vector. So here I'm creating a new counter vector called so in the ops, I have provided the help and description. And if you look at carefully, this also has something called constant labels. Constant labels in the sense, as I mentioned before, you cannot change the label values. That means both the keys and values of that labels, you cannot change that. But here you are only providing the label keys. And here, if you see, I am actually setting that particular, I have this beer API, all the permutations and combinations I am doing here. So for the API, I have 3 possibilities, beer, car, and delay. And for success, I have 2 possibilities, true and false. So I'm actually initializing all these particular values. So that's what, with the label values. So that's what we am doing. And then I am registering that particular counter. Similarly, the connection matrix, it follows the same approach, but here it is a gauge because it's the number of connections that you have. And here I am not segregating number of connections for beer, number of connections for car, number of connections for the other API, delay API. So I'm just accumulating everything into a single metric. I don't want segregated. I just want number of connections the server has. So that's what I am doing. So I don't need a dynamic variable like this. So I just created new gauge instead of a gauge vector. You also have that. And then you have histogram. Again, you also have histogram vector and summary vector. It again depends based on the use case, whether are you going to add one more label key and the value dynamically. So that's where you need to decide whether to use vector or that thing. So if you look at carefully in the ops field for the histogram, right? So I am providing the buckets. These are all the 9 buckets that I have provided: 1 second, 2 second, 3 second, 4 second, something like that. And for summary, I'm providing the quantiles that I want to calculate. So this is 50th percentile I want to calculate, and 90th percentile that I want to calculate, and 99% that I want to calculate. And this is the error percentage, that means error value that you can round off kind of thing. But essentially, these are the default. If it doesn't provide this, I think this is the default that summary gets picked up. That means it always generates 50th percentile, 90th percentile, and 99 percentile with error percentage, with error rate as this much. And yeah, again, it's the same thing. You create the metric called new summary and then register it with the Prometheus registry. So that's what you essentially do. So the flow is kind of like this. First, you have an SLI, you decide, you create a page. First, you go ahead and decide, okay, I have these SLIs, so I need to create these metrics. So let me go ahead. These are the metrics that I have. And you also need to decide how the metric should look like. So in the first counter, right? So I have decided myself. So I will have a label called API name and success. So these are the 2 label keys. And the available label values are beer, car, and delay. So with true and false. So these are the different permutation and combination that I have. It's good to decide that. If you doesn't know, it's fine. You can again dynamically create the API. You don't need to have that. So if you doesn't do this, there doesn't in it. So we will check that. We will see that. So up to this point, you have SLI. Then you decided what are the metrics I need to generate. Then you wrote the code for the Prometheus registry. Then you generated the metrics. That means you init the metrics. So you are not updating the metrics as of now as such. So what we will do, so let's go to the car API and see what it is doing. So this get invoke API counter, right? So this kind of returns the metric actually. If you look at the types, so in the car API, if you see get invoke API counter, so what does it return is nothing but this particular global variable that we just created. If it is null, we just create the counter, right? So we just created that particular counter vector. We are just returning that. And what we are doing is we are providing with label values as API name car and success true. And what we are doing, this API was invoked once. So that means we need to increment it by 1. So that's what we are doing. We are just adding value 1 to the metric. And if you look at the beer API, it's a little bit different. So here what we are doing is if the HTTP code is 200, which means we should return success, that's when we are success true and we are adding 1. Similarly, for the other case, when it fails, the beer API fails, we are adding 1. That means it failed. And the delay API, what we are doing is the same thing. It always succeeds, but it gets delayed. So delay success, add 1. And we want to calculate the how much time, how many requests are completed in 90th percentile, 50th percentile. So that's where get delay histogram, etc. All these, and we are just observe. So this is the function. Instead of we are just observing the value. Now in the underlying, Prometheus takes care of which bucket to keep for the histogram, and for the summary it calculates the data. So we are just putting in the delay, so which is again a random integer. So that's what we are doing. I hope this is good. Any questions? Now as I mentioned, we are serving all these in the slash metrics endpoint, right? So you can actually again go back to the this one and click like metrics. So here you see the metrics got generated. Let's look at the default ones also that was generated by so if you see, these are the default generated metrics, the process metrics actually, number of file descriptors open and max file descriptors, and uh, the CPU seconds total, number of Go threads, etc., etc. All these things you have here. You can use it. You can use it if you want, but if you doesn't need those metrics, so that's what in my scenario I don't need those metrics. I only need this. So let's actually take a look at. Let's again recreate the server. Make run server. I'm just deleting that previous one and again rerunning it. And if you see, everything was set to 0. So that's what I am doing. I'm actually in the init in the types. So that's what I'm doing here. I'm just resetting that values to 0. You have done, and if you see the histograms, they are by default will be init with 0 and not applicable, not applicable, and the present connections are 2. And if I invoke a delay API and again come back here, you might see increase. It completed. 1 second. Sorry. So it is again invoking, if you see, 2 connections. Again, it might increase. I'll just show that. So now you have seen this particular one. Okay. So the delay API was invoked 2 times. And so that's why you have the success equal to 2. And we haven't invoked these API set. So if I invoke car, so I got the response, and if you see, the response was changed too. And if I invoke beer, fail to process, that means we should have this one updated to 1. This one updated to 1. And again, if you can invoke this, fail, fail, fail. I got 1 success. So I should get 1 here and large number of failures here. So 6 times it failed, only 1 time it succeeded. So now I have written the client application, right? So what I will do, I will just run this client application, which kind of invokes the APIs instead of me running in the browser or curl command. So that's what it does. So if you see, it invoked the car API thrice. It got a response, and it invoked beer API thrice, and also it invoked the delay API thrice, and it is waiting for 891 seconds. So this happens. That's what this happens 10 times, 3 times each, invoking the API. Now, if you look at metrics, this is what it is. And if you look at 0.5 percentile is 8 seconds. That means half of the requests completed in 8 seconds. This might change over the course of this particular client application running. So you will have the client thing getting changed. Even if you look at the Prometheus, right? 29.5, that is something around 5 seconds. So if you look at 5 seconds, only 2 requests completed less than 5 seconds. So that's what it is. It's kind of same. That's what how you do the math. So the math will be done in the PromQL side, actually. And the number of active connections, because we have the delay APIs running for long. So that's where we have like 4 connections now. The number of connections increased from 2. So if I increase the go to client, is this. If I increase this, go to client and sorry, it opened here. So number of go routines to 6 and number of iterations I kept it to 1. If I do that, let me stop this and rerun this one. I might increase the number of connections if the delay is large. Yeah. Again, slowly it will decrease over a period of time because 3, 4, 6, 7, so and 10. Again, they got decreased. They got again back to 4. Okay. So now we have the application. So we have the metrics. We generated the metrics. So now the next part is configuring Prometheus to scrape these metrics, right? So for that, so go to the Prometheus.yaml and let's comment out this part and comment out this part for now. Okay, so now if you see the Prometheus config, right, Prometheus.yaml, it kind of looks like this. So these are the scrape configs. That means from where to scrape the metrics, and this is the scrape interval, that is 1 second, and scrape timeout. That means if the response wasn't reverted back in 1 second, right? So that's where we kind of ignore the error, and the scheme is HTTP, and we are using a static config. That means we will provide the targets and those things. So this is the server, the KCD server that I was running on my thing. And if you look at, I created this KCD network, right? So why I created this KCD network? Because I can reference the Docker containers using their Docker names, container names. So whenever I'm running a Docker container, I'm actually giving the name. So if you see run server, so I'm providing that name as KCD server. So you can, so inside the application, you can just directly invoke this particular container using this particular container name. So that's what that's the reason why I created a separate network for running this. So here KCD server 90, and when the metrics are getting scraped, if you want to add any other extra data, so any other extra data in the sense, any other extra labels that I want to add. So here I am adding a label called KCD server Docker. That's what I am actually doing. And KCD server default. So these are the default metrics that I'm scraping. If you see here, I explicitly provided the metrics path to scrape from. Here I haven't, because by default, if it doesn't provide any, it assumes /metrics is the endpoint. So again, for this, maybe KCD server default metrics, and I will just say metrics, right? So now we have this particular config present. So how do you run it? Make run Prometheus. Again, in the backend, if you look at the Prometheus, run Prometheus, right? So you have the configuration. I'm just mounting this particular config to the container and blah, blah, blah. Don't worry about these rules. I will come back to that. So I just need to make run Prometheus. So yeah, if we look at Docker PS, we have the Prometheus running on 9090. So let's open that. It's too big. Yeah. So now you have the Prometheus up and running right here. If you look at up and running, and you have these tabs, alert, graph. So graph is where you can run this is the place where you can run the PromQL queries. And here you have status, which kind of gives runtime and build information. That is, what is the Prometheus commit ID, etc. What if you see build information, what is the commit ID, etc. What is the Golang version used, etc., etc. All those things. And TSDB status is kind of like what is number of time series data it got, etc. All those things. And that might not be that much configuration. So if you look at this particular configuration field, right? So this is what we have provided actually. So the KCT default server and the scrape config. So these are the default values that Prometheus adds. Scrape interval is 1 minute, but we have provided scrape interval as 1 second. So it will scrape for every 1 second. And targets. So we configured 2 static configurations. So here we have this metrics endpoints and the default metrics. And if you see, I have added labels, right? So Prometheus also adds its own labels. So Prometheus adds job equal to the scrape name, KCD server and KCD default server, KCD server and KCD default server, and the instance where this particular one is getting picked from. That means the target it adds. So these are the 2 default ones that are added by the Prometheus itself. And we have added this particular metric. And if you see, both the state is up. So they are both healthy. We don't have any unhealthy nodes. And now we created this matrix, right? So let's try this out. So PromQL is very simple. You just provide the metric name. So you already, I think that was already indexed. So here you can actually see the 6 different metrics that you have here, right? So you can look at, okay, this. So this green one, API invoke count is 13 times that this particular API, beer API was invoked, and 30 times it failed. 13 times it failed. And here it is delay API was invoked 11 times and the success is true. That means 11 times it is successful. Car API was successful 10 times and the beer API was successful only 3 times. So now I got my details in the Prometheus. So you can just increase, but this is not that great. That means if you want to add one more table, right? So you have to again click on this add panel. This is not a good UI. So you doesn't use Prometheus to visualize the data. You use Grafana. We will again get back to that, how to do that. I'm just changing. And we have the summary, right? Delay summary. So this is what I wanted. So the delay summary. So this is how you can again, let's say, I will again go back. API invoke count. I only want the beer success, the beer API success. So what I can do, API name equal to beer and success equal to true. So it was only successful 3 times. And let's say I want car API. Now let me do one thing. Let me also run the make run client so that the metrics are again changed. Okay. If you see now, suddenly there is an increase in the data because the beer API was the car API was invoked how many times? If you go to the main.go, sorry, not this one. It invoked 6 times extra. So that means this is 10, this is 16. Yeah, this is 16. Now I only want APIs that got successful. I don't want to monitor failures. So if you see, this is how the data changed. For delay, you will see the data increment slowly because there is a delay in processing the request, right? So you will see, but for car, it is instantaneous because they return fast. And Beer API also succeeded once, it seems like. So you got one more data extra point. And now you can actually see the, yeah, it is still running. So delay summary, sorry. So if you look at here, the 99 percentile is 6 seconds. That means 99% of the requests are getting completed in 6 seconds, right? So that's what this particular one does. And if you look at 50th percentile, 50% of the requests completed. But if you look at the previous data, so here 99% of the requests completed in 10 seconds. This might be because most of the delay happened around 9 or 10 seconds. So that's why you have the delay like this. Here we are lucky. The delay, the random generator was less than like 4 or 5. So that might be the reason. But then again, it can increase based on the delay that we are getting here. So if you see here, most of them are 2, 4, 5, 6. So that's the reason why the delay that you get is, that's the reason why the 99 percentile again came back. Now histogram, if you look at, so histogram quantile, I think it was actually, so we have, what is the metric name for the histogram? So this is our delay histogram. So I will just go here. So this is the PromQL basics kind of thing. So it kind of have some functions like how you do plus, minus, greater than. So that's what we actually did. So let me give you, so this particular repo that I was showing you has some basic commands. Again, you can actually, so there is a, if you are not running the Docker containers and having this on your local setup, right? So there is something called prom lens, where you can, but you doesn't know what are all the metrics that you have. So you can actually start typing like up. So there will be always a metric called up. So which kind of says what are the endpoints that, okay. So if you see, right, this particular up metric is for every scrape config that Prometheus instance is pulling from. So if you again go back to our Prometheus instance, and if you run this particular query, you get one. So that is KCD server default metrics. So we have two actually. So one of them is, two of them are coinciding on top of each other. So both of them are up. So let's say one of them is down. So I will just show you. So let me go ahead and edit the Prometheus config, prometheus.ml. I will add one more. So I will add this, something called node exporter. So what this will do, so we again need to restart the Prometheus. It's not essential you need to do that. So there is also a functionality through which you can reload the configuration dynamically using a web endpoint. But yeah, we are not showing that. Now again, if you, so you have 3 now. So this default matrix is up. This one is also up. Seems like this one is down. So this one up is 0. That means that particular scrape config is not up. Similarly, if you look at the prom lens thing, right? Again, the link is provided here if you want to take a look. Here you have these, you have C advisor, you have a demo service 1, 2. I think these are replicas, 3 different replicas, and you have hub exporter similar to node exporter. You also have the node exporter here, and it is scraping itself. So Prometheus as a server, right? It generates its own metrics. So it is scraping its own metrics by itself. So that's what here it is doing. So I had just given the basic example. So now, again, going back. So now you have something called, now you have application, you made changes to the application to generate metrics, then you configured Prometheus to scrape the thing. Let's again go back and see what this particular node exporter is. So this node exporter is kind of like, let's say you want to get metrics from the Linux kernel. So you cannot go and instrument the Linux kernel to generate those metrics for you. You cannot do that. Linux already generates the metrics in a different format, but stores them on disk and generates the metrics in a different format. And now you cannot go back and make changes to the Linux kernel and generate Prometheus metrics. So in that scenario, what happens? Prometheus has this concept called exporter. So you write some code which kind of converts whatever the kernel data into the Prometheus data and exposes that as Prometheus metrics. So let me run that. So if you look at, so Prometheus exporters, right? So there is a large database of different exporters that you can run. One of them, the most famous one, is the node exporter. So which exports the underlying OS metrics. So that's what I was using. So I will run that as a Docker container here. So make run node. So let me check if it is running properly. So yeah, node exporter is up at 9100. So if I again go back 9100, if you see, these are all Go related metrics, but then you will also see what is the node CPU seconds. System is using one CPU with for this many seconds. And if you see, this is a counter. And the node disk discard time, etc., etc. All this, there will be a lot of metrics that you can analyze and do that. So this is what I am scraping. And if you again go back to our Prometheus instance where we have configured, if you see, the node exporter is also up now. Previously it is not up. Now it is up. And if you again go to graph and so if you see, suddenly the 0 changed to 1 again. So you have everything up and running. So okay. So now we have the node exporter, which is collecting the metrics from the underlying Linux kernel, and you have your server generating the metrics, and you have Prometheus that does that. And a little bit of PromQL on how to query the things. So I'll just give one more example. Again, the PromQL itself might take more than 3 to 4 hours to explain different functions that we have. But essentially, you can get, it should be straightforward. So once you start learning and looking at the documentation of the PromQL, right? So you'll get more. So if you look at this particular query, right, I'll just copy paste in here. So this is what I am actually doing. So I'm calculating the API invoke count success equal to true. So when I do this success equal to true, I will get three different data points, one for car, one for beer, one for delay. I'm actually summing all those three different data points, which is nothing but sum of all the API invoke success, and I'm multiplying it with by 100. And in the below, you can see I'm actually calculating the total success percentage, actually, kind of the success percentage. So if I run this, the whole suggestion applications, the success percentage is 67. And let me again run the client again to simulate some data for you. It again tanked, seems like it again went back, maybe because the beer API again failed. Okay, again it increased a little bit. It went to 68%. Might be because we get a little bit successful. Okay. So slowly this will again go below that. And in case if it doesn't want cumulative sum, we can just kind of remove this sum so that we get percentage, we get the percentage for each and every API. Oh, my God. So here I am actually calculating, So here, this is what it is doing. I'm trying to get, so I'm grouping the things by API name. So if you see the success for beer API is 18%, and for both the delay and car API is 100%. So that's what it is. So you can do a lot of manipulations with the PromQL queries. Again, it is vast. You need to understand what you want to do, then go ahead and read the documentation and go one by one. So that's what you can actually do. Any questions? Okay. So now, again, going back to our thing. Okay, now again going back. So there is something called rules. So rules are kind of like they kind of so let's say I have this particular PromQL query. I don't want this to be executed each and every time, right? So what I can do is I can change the Prometheus configuration in such a way that I can tell Prometheus, whenever you get some data, configure this particular query and store it as another metric altogether. So that's what I can do. So that's what that is nothing but a recording rule. So that means you get the data, you transform it to another metric and store it in the Prometheus. So those kind of rules are called recording rules. So that's what you can do. So let me just quickly show that how it looks like. So you need to provide this particular rules configuration where the rules are present. And if you have the rules here, so you have recording rules that I'm creating. So what I'm doing is I'm actually generating this particular PromQL query and storing that as API success percentage, right? So this is what I'm actually doing. And the next part is alert rules. So this is where you kind of create alerts for your metrics. So what I'm doing is I'm again creating an alert called a high load alert when the present connections is greater than 5 for 20 subsequent seconds. And I am adding some more labels called the severity high, etc., with some annotation when the alert is generated, right? So this particular data will be pushed to the alert manager. So we are not looking at alert manager configuration, but yeah, I'm generating alerts. So these are nothing but alert rules. So if you look at these three ones are kind of similar. So let's say I have my constraint was above 70, but I cannot wait until 70 is hit, right? So I need to be careful when the percentage is less than 90. I need to make sure what is going wrong, and if it is less than 80, it means I might hit 70. So I need to get an alert when it is less than 80 also, so that I can go ahead and see, okay, this might go below our SLA agreement. So I need to be careful. So this is where we are below the SLA agreement. So I'm generating different kinds of alert. Again, if you see the labels, I'm adding the severity as the risk, severity critical. This severity below 70 is blocker. Again, I am using this particular query. What is the PromQL query for which the alert needs to be generated? Is this clear? So this is what the Prometheus rules meant. That means you have recording rules where you can convert the existing data into a new data altogether, and alerting rules where you can configure the alerts and those things. So yeah, that's what these two slides are meant. So let's again rerun our Prometheus. I will rerun again the server. Make run. I'm also rerunning the Prometheus. Then I will rerun the client now. So before running the client again, let's go back and see the targets. So all of our 3 targets are up, and the configuration, if you see, now it has rules.yaml, and you should be able to see the rules here. So we have something called alerting rules that we created, and these are the state okay, whether it is firing or not, and recording rules state okay. You should be able to use this metric after some time once you can actually. So now I will start the client here. Okay, it is running. So let's go to the alert. So if you see, I have the number of connections as 5. It is in pending state. Why it is in pending state? Because it's because I kept for 20 seconds, right? So if the value is greater than 5 seconds for 20 seconds, then the alert will be in firing state. So I think this again go back because the number of active connections are not that high. So the present connections are less. But if you see the API success rate, all the 3 are firing state because the percentage is less than that one. And let's take a look at this one. Go back. We configured this recording rule, right? Called API success percentage. So if you see the success percentage for Beer API is 16%. And if you see, this is not a metric that we generated actually. This is the metric that was generated by Prometheus using the recording rules. So that's what the flexibility that you have with the recording rules. So every time when you run a PromQL query, the Prometheus doesn't need to compute that particular data, because it already computed whenever the data is coming, and then it can just present it on the fly. Okay. Now this part is fine. So we were able to generate. Okay. One more thing is. Sorry. So if you see here, it kind of shows alert, whether it is the metrics you see, right? Alert state is pending, and alert name. What is the alert name? Again, this comes from the Prometheus configuration that we have in the rules. What is the alerting rules in the alerting rules, right? So we have rule type alert, and what is the alert name? This is the alert name. So that's what it is using. So alert state is firing for the API name beer. So because we only want for a particular API, that means API name. So these are templating which are available during. So again, can actually refer to the alerting. So this is the page where you have all this configuration, notification template references. You can actually refer to this page to understand what are the variables that you have available when you are running. So now we have this particular, we have application. Again, going back to our starting thing, we have application, we have SLIs or SLAs, then we have generated the metrics, then we configured Prometheus to scrape those metrics, then we configured alerting rules or recording rules so that we can fire the alerts. So up to this, it's fine. But how do we get the notification? That means how do I get the notification, etc. All those things, right? So for that, so what I did was I am sending the notification. So I need to configure the alert manager in such a way to send whenever the alert is firing state, I need to get the notification on Slack at different channels, right? So that's what alert manager kind of does. It kind of routes those particular alerts to the different uh, uh, Slack messages, Slacks, and all those things. Okay. So now what I will do to this point is okay. So for the alert manager configuration, again, this is simple. So on the Prometheus config, you need to provide the alert manager configuration like this. So the alert manager is running, which will run shortly. I'll do that. So I'll uncomment this part. So you have the alert manager. So I have the Slack incoming webhook. So that way through which I can send Slack messages, right? So this is in a file. This is a secret, so that's why I haven't uploaded that to GitHub. You can generate your own Slack webhook, incoming webhook by yourself. Again, if you want to configure it to mail, there are you can find examples on how to configure it to mail or PagerDuty or whatever it is. For this demo, I am just using the Slack, right? And then I need to, so in the alert manager configuration has three important things, three important sections. One is receivers. So receivers is kind of, as the name says, what is the receiver configuration? Let's say team suggestion. So I have configured team suggestion, and the Slack configuration, Slack channel name is, that means for team suggestions, the Slack message will be sent to Prometheus Alert Manager. And for team beer, it will be sent to a different channel altogether. And for team car, it is the same alert, same channel. So this is what the receiver configuration. Again, this can change depending upon if you are using mail, PagerDuty, etc. for the Slack config. So you just refer to the official documentation of Prometheus on how to do the other things. Now, the next important part is root. Root kind of defines to whom the Slack message should go. Let's say you have an alert that is getting fired, and to whom that particular alert should go to. Here, so group by severity. So if you see my rules config, right, previously, I will just paste it in the, yeah. If you look at the severity, I have severity. So I'm just grouping all the alerts by this particular label. And then what I'm doing is the default receiver is team suggestion. That means if you are unable to find any receiver, then the default receiver is team suggestion. And then I have configured my route something like this. If the API name, that means if the label, if it has a label called API name and the value is beer, send it to team beer receiver. And if the alert has a label called API name and it with value car, it goes to team car. Let's again go back and see the time. So if you see this particular API success rate, here it has an API name called beer. So that's what it is firing here. And high load alert doesn't have that. So it won't match this particular query. It won't these two queries. So it will gets defaulted to team suggestions. So actually there is I already told you about receiver, the root config. This is what it is. First, we will try to match the team car. If you are unable to, it goes to team suggestion. We will also try to match the team beer. If we are unable to, then it goes to team session. You can use this particular web tool. You paste the whole configuration, alert manager configuration, you get this particular graph, how the routes are configured. So this is what the alert manager route configuration is kind of like. That means we don't want to send beer related failures to the team suggestion Slack channel. We don't want that because it is almost failing continuously. So we want to configure a different channel for that. So that's what I did. And then we have something called inhibit rules, which kind of use like, so again, go back to the rules. So let's say the percentage is 70 bytes from the starting, from the scratch. Then we don't want Slack alerts for these two. We don't want Slack alerts for 80 and 90. That means we want to suppress those two alerts. So that's where you do the inhibition rules kind of thing. So what I'm doing is, if there is a severity called blocker, right? If it is matches severity blocker, then I don't want severity critical or risk to be fired. So that's what I want to suppress. If the blocker is getting fired, suppress critical and risk, and the match is this thing. And if the critical is getting fired, I want to suppress the risk. I don't want 3 alerts. So let me just show you how it looks like in action actually. So I have this Slack workspace that I'm using. And here you can actually see the Prometheus. So here, if you see, I have the 3 alerts fired. I don't want that particular scenario. I only want only one. Success rate is below, it's a blocker, something like that I want. So now again, so I'll do this. And let me check Docker PS. Let's see what will happen if I comment this particular piece of code out. Make run alert manager. The alert manager is running, and alert manager is running at 9093. So you can actually go ahead and get the alert manager configuration also. So you don't have any alerts as of now. Oh, I need to restart the Prometheus instance also, so that I haven't restarted the Prometheus instance after changing this particular configuration. So I'll just do that, make run Prometheus. And then also I will run make run client to simulate the data. Again, I'll change it to some 10 iterations. It will run for long. I get the data. Okay. So again, coming back here. So nothing is there. So far, so good. So we have these in pending state. The alerts are in pending state. So when they are fired, so they are active. Now you can come here and look here. So you can see you have 3 alerts: severity, critical, risk for the same API, which you doesn't need actually. So shortly you should actually see a Slack message getting popped up here. In the meantime, any questions? Do you need anything you want me to elaborate? I know it's too fast because of the time that we have, but yeah. Okay. So you can see here now I got 3 alerts, which is something that I don't want. So that's where I will again go back and change this particular alert manager configuration to add the inhibition rules, right? So it is running. Let me restart this one and different. Make run. I again restarted the alert manager here. So the alert manager configuration, it needs to pull in the alerts again. Oh, I need to again restart. Yes. Don't need to, but I will just restart just to. So they are active. All of them are active in pending state. Let me see if they get filed. So they are fired. You can actually go ahead and, but if you see this time now we only have one blocker because the inhibition rules that we have written, right? So they kind of suppress the critical and risk related alerts. So that's what the inhibition rules are kind of thing. So that's how you can configure the alert manager to the receivers, routes, and that particular one. So yeah, now you can see you only got one alert, which is for blocker. You didn't get risk and critical. This is particularly useful when you have a wide system outage, right? So wide system outage, you don't want alerts for each and every data point. So you only want one metric, which is at the top, that is, okay, there is a wide system outage, which kind of suppress the remaining alerts. You don't want multiple things. So exporters, I already told, this is push gateway. Now I will again restart, make run push gateway. So push gateway is something that we push the metrics, right? So I just started the push gateway. So push gateway is at Docker PS. If you look at 9091 port, so you just need to go and, so push gateway doesn't have any metrics as of now. Let me go ahead and run a particular ephemeral job, short-lived job, that is make run job, which kind of pushes the data to the push metric, right? So it is, in the meantime, we will just look at the code it actually pushed. That's first. So here I'm doing nothing. So I'm just creating a metric. Again, it's the same philosophy. And there are some Prometheus functions, push gateway functions that you can use to push that particular metric into the push gateway. So you need to provide what is the push gateway URL that you need to push. Here I'm creating the push gateway object, and then I'm doing the push. So now if you go here and check, you have the new metric available. So I pushed a gauge, and yeah, this is the labels that I have. So this particular staff name, Ambrose, kind of processed Angeline, Candice, Jesslyn, Luther, and Michelle. These are the delay, how much time it took to process that particular data. One drawback of push gateway is there is no automatic delete. That means it stays on forever unless I go ahead and delete these particular metrics. So now you need to configure Prometheus to pull the things from this. So what I have done, I created one more Prometheus instance called secondary Prometheus that kind of gets things from the push gateway 9091. So let me spin it up. I think it's secondary Prometheus or so, and this one is running at 9092. So I can actually quickly go ahead and look at 9092. And you can see the push gateway is up and running, and you can query that particular data. Again, it's not deleted unless you go ahead and delete it from here. So you don't have anything because there is only one data point. After this, the data is not present. Again, if you need the data, you again need to run job, which kind of, this is an ephemeral job again. It kind of generates and pushes that to the push gateway. So you should be able to again get the data again. Now the staff name is Christina. Before it was a different one. So you can again see the data here. So that's what the push gateway is. Now everything is fine. So everything is good so far. We have made our application and made all the monitoring stack available, everything. Now let's look at the dashboards creation. So for that, we essentially use something called Grafana. So Grafana is primarily used to visualize the data and creation of the alerts and all those things. But as we have alert manager, we are not going to use Grafana as an alerts for configuring the alerts. We just use it to visualize the data. So before going there, right now I have two Prometheus instances. So okay, I will come back to that later. So one good thing with Grafana, right? So there are a lot of, you are using node exporter, right? So there are a lot of existing dashboards. So dashboards are can be imported as JSON configuration files. So there are a lot of the default JSON templates that you can use to put it in the Grafana visualization, where you get all the nice and fancy visualizations and stuff. Because if you are using from node exporter matrix, there is some other person who is configuring the dashboards. It's same for him and for you also, because it's the same metrics. So that's what you can also contribute to whatever dashboards that you want and put your dashboard available in the Grafana dashboards link. So that's what I'm going to do. So I'll just make run Grafana again. So now I have the Grafana running on which port? Docker PS. So I have the Grafana running in, sorry, my bad, 9200. So if I go to 9200, so I need to log in. So admin is the user and password, and you can configure whatever you want. So it comes with clean slate. Now the first thing that I need to do is I need to go to connections. I need to do something called Prometheus. So first, let's configure the first Prometheus instance that we have run. KCD Prometheus 9090. I think that it is KCD Prometheus, right? Yeah, 9090. And 7 test is okay, 909. Sorry, my bad. Okay, the details are working. So now you have configured the Prometheus. So now the next thing that you need to do is go to dashboard. So here we already have node exporter metrics getting there. And I already showed you here, you can pull that thing. So I already downloaded and uploaded that particular one. So the only thing that we need to do is import. So I'm importing that particular node exporter. And I will use the default source. Last 5 minutes. So here you can see the different dashboards that you have. So that's what one good thing with Prometheus. So you can share your dashboards with others and they can just import and done with it. They will get all the details. Now let's say I want to create my own templates for suggestions applications. So that's where I have already created. I'll just import that. Very few dashboards I have created. I'll just import. So I have two panels. One is the alert panel, which kind of says you have 3 alerts that are getting fired. Because of inhibition rules, we only have 1 alert. And HTTP load alert, right? If you see, we have 4, 3, 2, 4. And again, we have at one point, we have 10 requests. Also, now it is 4. And we only have, that's what, if we only went above 5 once. So that's why we have this particular data. And this is a pie chart that depicts the API invoke success. If you see, the B success is like very less. And this is 42, 42, and 6% is only out of the 100%. And the failure is 100% beer API. There is no other that thing. And the success percentage in a line. This is a pie chart, and this is, you can use a lot of different mechanisms of visualizing the data. So that's what Grafana is primarily used for. So that's why I configured that thing. And last but not least, we have something called Prometheus Federation. So now you have 2 Prometheus instances, which are scraping the metrics from 2 different locations. Now what you need to do is you need to configure those 2 Prometheus in the Grafana and do the visualization there, which kind of difficult. So let's say you have one more comes into picture. You again need to add that to Grafana and do all the dashboarding and all that. You doesn't have a kind of a global view kind of thing. So what you can do is you can configure a 3rd Prometheus that scrapes the metrics from the first 2. So that's what this Prometheus Federation scraped on. If you look at the config, so it is configuring from KCD Prometheus, the first instance, and it is configuring, it is scraping all the metrics with job equal to with these labels. All the metrics with these labels, and from the second Prometheus, it is configuring all the metrics with this. So now what I will do is, sorry, make run. I need to find the command. And it is running on 9094 port. So I'll just quickly go here and I think there is some mistake. Okay, I'll just show this. So it seems like it is not the configuration is yeah, we have the configuration KCT secondary everything. So we have this scrape config, and if you look at the targets, yeah, this is up now. So we are actually pulling from the KCD Prometheus and KCD Prometheus. Now the only thing that we need to do is go again back to the connections and your connections, and what I will do is, instead of pulling from there, pull from Docker PS Prometheus Federation. So data source is working. Now again, you can again go back to your dashboards. You will still see the data. Now you don't need to again configure.
Hey,
don't need to
sorry to barge in. A quick time check.
Yeah.
Okay. I think
Sure.
we have Yash's activity as well, I guess, right?
Yeah, sure. So that's what Prometheus Federation is. Yes, do you want to quickly show the Kubernetes?
Yeah, sure. So like,
do you want to share screen, or?
Yeah, I can share the screen.
I will make you the host. Yeah.
Yeah, so like let's talk about Cube Prometheus first. So what is Cube Prometheus? So Cube Prometheus is actually a like if when you think about like Kubernetes cluster monitoring stack, so Cube Prometheus is something that makes it easy. And so I have just updated a README there. You can maybe pull do a git pull on the repo, like so that you can have all the commands handy. So yeah, this is what the README I have put for installing on the Kube Prometheus. So it's basically monitoring on the Kubernetes cluster. So what Vamsi have gone through is through the Docker. He have the Docker image, and he installed the Prometheus. But now we will see how we can install Prometheus on Kubernetes cluster. And so we will be doing this with the help of Minikube, and yeah, and there is like Cube Prometheus project that will be that we'll be using for this. So I hope you all have the Minikube installed, and so it like maybe you need to delete the Minikube cluster first, and then restart it with this configuration. So maybe I can do along with you, and like let's do the quick hands-on on it, like how we gonna do it. So so yeah, I'll check my Minikube status. I can just increase the font a bit. So yeah, I have a Minikube running and configured. So like, do you all guys have Minikube, or do you want me to share how we can install Minikube as we are already up on the time? Like if you want, you can go through this README and like try it yourself, and like in between I can also show you how we are doing it, like in quickly 10-15 minutes, and then maybe you can wrap up. So I already have a Minikube installed, and right, and like I have set it up with this particular configurations with the Minikube on the Minikube, right? And so for Cube Prometheus, we need to see. So this is the compatibility like table of Prometheus that you want to install. So whatever the Kubernetes version you have. So I'm on, like, if I do kubectl version hyphen short, so it will just show me like what are the Kubernetes version I'm using. So it's like 1.25.2. So yeah, so that's important to check before like installing a Prometheus. So like for 1.25, I'll be using release 0.12, and I have this. So let's clone this Prometheus repo. And like I'll just cd into Prometheus what we have. Dallas, it has everything now. Now I can check out. So like this is important. Like I'll just need to check out to the particular release which supports the particular version. So for 1.25, it's 0.12. Like this is the source where I have taken it, right? So I'm checking out to 0.12, and then we'll just apply the manifest what we have. Like, so this will take care of having the all the namespace and what all, right? So it will take care of installing the namespace and the CRDs that we want for the Prometheus to have. So I think I already have that. So you can do that with that. And once, like, so this is runs into a step, because first we have to have the namespace and the CRDs defined. Then we will wait for it to have that like up and running, and then we will do a kubectl apply for all the CRs for which we have defined the CRDs in the first step, right? So that's why we have to do this into the steps. Uh, Yep, and after this, we'll just do the port forwarding on the particular port, such that we have this Prometheus thing up and running. So so I already have this. Let me just, okay, yeah, this. Okay, yeah, so I already have this port forwarding on the Prometheus 9000. So if I go to my browser, little quick, and if I do localhost 1990, it has this Prometheus up and running, right? And now what we'll do is so we have this Prometheus. We will just go and up the other things like alert manager. So we will be having this alert manager up and running on 1993. So let's do a port forwarding for this. I'll just copy paste. So it's running on 9093. So let's check this. Yeah, so this is also up and running, and now we can make the port forwarding for Grafana. So it's a command. So this we will be doing it on port 3000. So let's do that. Yep. So we also have Grafana. So let's check that whether it's up and running or not. So we have this. Also, and you have to give an admin as username and password as of now. You can maybe set it up later if you want to. I can just skip it as of now. And it has this Grafana also up and running. So maybe what I'll do as quickly as like how we can have a simple like uses of Prometheus and Grafana dashboard, like as Vamsi has also given a glimpse on it pretty much, but I'll just do a quick deployment on the Kubernetes cluster and show you what it is showing. So if you just go into README and see, like, I'll just do this kubectl apply on this. So this is a deployment I'll be creating. So let's create this deployment resource and okay, it's taking a while. Okay, okay, maybe the website so much fetching is slow, so I can have the URL is not working, so let's create a deployment pretty quick. So I'll just let's ignore this. I'll just do pi and create a deployment.yaml, and like is the deployment resource, right? And so its name is nginx deployment. I'll just do a kubectl apply on this. Yeah, so the deployment got created. Now we have a stateful set that we want to deploy. So let's try this if this works, or otherwise we'll create a different. Okay. Okay, this is also not working, so I'll just quickly create a stateful set. So let's create a stateful set.yaml. So I just took to a kubectl apply. Yep, so we have this service and stateful set created. Now what I'll do is I'll just we'll see into like we'll explore the metrics in Prometheus. So we have this Prometheus up and running here. So we'll just try to see like observe the Kubernetes cluster into this, like what's all there. So let's so in the metrics explorer, let's use the let's see what's the the deployment that we have created. We can query this and see what all the deployments we have. So if we see, we have created this nginx deployment just now, right? So I can use that. And if I execute it, this will show the graph of it, and it will. So it is showing here that I have this deployment created, and with this kube deployment created, and this is that the namespace default and all that stuff. So yeah, so this is showing like the deployment that we have. Similarly, like in Grafana dashboard, we can like let's try to see this in Grafana. So if we go into Grafana dashboard pretty quick and do like so in Grafana we'll try to import a dashboard that's already exists. So we'll try to import this Kubernetes cluster Prometheus dashboard that is pretty popular. So I'll just copy the clipboard ID, like this dashboard ID, and I'll just try to import it with this ID. So let's try to load it. So it's loading. It will take so this is asking like the data source. So data source will be Prometheus for us, and I'll just import it. And now we can see like what are the replicas we have and a number of nodes and pod usage and all. It will show everything. So like that's how we can like do the deploy the use Prometheus to have the monitored the Kubernetes cluster. So it's a very quick one that I was shown because like we are running out of time. But yeah, if you have any questions, feel free to ask it now, and or if you are facing any challenges in deploying it or having it, please feel free to ask.
I think that's all we have for this session, folks. Remaining everything, the next part is from what's next. So we have demoed Prometheus and Prometheus operator. So there are some drawbacks with Prometheus, right? So it cannot scale.
Okay,
That
sure.
means,
Mm-hmm.
yeah. Can you make me the host?
Yeah, sure.
Just click on my name and make host.
Yep.
I think I didn't get the host, but yeah. So if you look at the what next slide, right? So Prometheus doesn't support horizon, scaling properly. That means if you have a load on the system, what you do, you just increase number of replicas, but you cannot do the same for Prometheus. You cannot just keep on increasing the number of you need to increase the storage of the pod or the node where the Prometheus is running. That is one of the major drawback of Prometheus, because Prometheus stores the data on the same node where it is running. So you have to increase the size of the disk. You have to put more RAM, more storage, more CPU into that particular instance where the Prometheus is running, so that it can run, it can scale up. So which is a major problem. So that's what, so that particular drawback is addressed by Thanos. So Thanos provides unlimited storage and global view. So that is something that you can dive into further after understanding all these concepts that we have just showed you. So Prometheus operator, that I think that's what is just showed you on how to configure Prometheus, is way of that thing. So that's all we have. If you have any questions that we can take up, otherwise I think Pavitra and Veera, they can take it further.
Yeah, thanks a lot. Thanks a lot, Vamsi, and thanks a lot, Yash. So I think if you have any questions, okay, I think we have one. Either of you, would you like to take it up? So the question is, will you be sharing this Git report to practice later? Okay.
Yeah, the Git repo is public. You can just try the things out. Most of the configuration that the commands that we just ran are available. We'll just keep it public.
All right. Yeah. So considering the time, I think if you have any further questions, I'm just pinging you a mail ID. You can drop in the questions there. We'll take the responsibility of reaching out to Yash and Vamsi and get it answered for you. And yeah, thanks a lot, both of you, for your time, and thanks everyone for joining us. Thank you.
Yeah. Thanks everyone for joining.
Thanks all. Nice weekend.
Bye-bye.
Thank you. Thank you, everyone. Yeah.